Welcome to another video on reproducible reporting. In this video, you'll be learning about reproducible workflow using version control. By the end of this video, you have a solid understanding of reproducible workflows and how to manage projects with version control. We will explore why reproducibility matters, how to use Git as a version control system, and how to collaborate effectively on GitHub. You also learn practical techniques such as initializing a repository, staging and committing changes, branching and merging, and pushing your work to a remote repository. I will guide you through a hands-on workflow that includes creating a Git repository for your project, making incremental commits, employing branches for new features, resolving merge conflicts, and open pull requests on GitHub for team collaboration. With these skills, you'll be well equipped to maintain a transparent, reproducible project history and collaborate effectively with others. What is reproducibility? Reproducibility is the ability to obtain consistent results using the same data, code, and computational environment. And it has the following key components: data, code, and environment. By data, data must be clean of errors, version as it evolves, and documented via metadata. The code must be organized into reusable scripts or functions, clearly commented and tracked with version control. By environment, exact software and packaged versions must be recorded, for example in a log file, and if needed, encapsulated with containers. Reproducible workflows reduces potential for errors, increase transparency and accountability. It also makes research more accessible to others, facilitating collaboration and replication studies. Similar to track changes features in Microsoft Word, a version control is a system that records changes to a file or set of files over a time so that you can record specific version later on. It allows multiple people to work on the same files without overwriting each other's changes. And it has the following benefit: track changes. You can easily view the history of modification, and by collaboration, you can easily merge contributions from multiple team members. And by safety, you can easily revert to previous states in case of errors. Git is a distributed version control system that was created by Linus Torvald in 2005. It is one of the most widely used and well-known version control systems in the software development industry. Git is known for its speed, flexibility, and ability to handle projects of all sizes, from small personal projects to large-scale enterprise applications. And we also have other version control systems that includes Mercurial, Subversion, and Parvos. And Git is by far the best. Installing Git is straightforward. It begins by downloading the appropriate version from the official Git website, and you can visit git-lcm.com/download. The process varies slightly based on your operating system, so be sure to follow the platform-specific installation instruction. For example, for Mac OS, click on the Mac OS download link, and for Windows, you will click on this when you get to this website, and for the Linux or Unix, you will click on this for the Linux computer. After installation, verify the setup by running the git version, and this will show you whether the Git is actually installed successfully or not. Let's now look at some Git commands. To create a new Git repository in the current directory, you will use the command git init. This will initialize or set up a version control system for your project. And by using git status command, this will show the current status of your working directory and the staging areas, indicating changes that are staged, on stage, and on track. You can also use git add command. Git add command adds specified file or all changes to the staging area in preparation for the commit. And you can do that by using git add and the name of the file, or you can just use git add dot. This will put all the files into the staging area. Git commit -m record the stage changes to the repository with the descriptive message. The message is what you will put under this quotation, and this store information about the changes made, the author, a timestamp, and a commit message depending on the purpose of the changes. And whenever you are using git commit -m, make sure that you have a descriptive message in this quotation. When you run Git status, Git provides you with a snapshot of your current work environment. For example, working directory. This is directory where you are actively editing your files, and any changes you make here are considered on stage until you explicitly add them to Git. Staging area or index is an intermediate area where you prepare files that will be part of the next commit. When you run git add, you move changes from the working directory to the staging area. These changes are then staged for committing. Stage changes. These are intermediate area where you prepare files that will be part of the next commit. When you run git add, you move changes from working directory to the staging area. These changes are then staged for committing. Unstage changes. These are the modifications made in the working directory that haven't been added to the staging area yet. Untracked files. These are new files that Git doesn't recognize because they are not yet under version control. In summary, running Git status gives you a clear view of which changes are ready to be committed, which changes are still being worked on, and which new files have not been added to the Git yet. Git push command is what gets your code into the remote repository in either GitHub or GitLab. We will discuss about this in the later section. Git allows you to manage your project effectively by using branches to isolate changes. For example, creating a branch with Git branch and its name lets you develop features or fixes without affecting the main branch. You can easily switch between branches by using git checkout and the branch name. You can even merge your work back into the main branch by using git merge and the branch name. And once a branch is no longer needed, you can delete it by using git branch minus small d and the branch name. Now let's see them one by one. For example, to create a new branch named new analysis, you use the command git branch new analysis as I have shown here. This will now create the new branch for you. You can also switch to another branch by using git switch and the name of the branch as I have done it here. As you can see, git switch, then you put the name of the branch that you want to switch to. In fact, you can easily create a new branch and immediately switch to it by using git checkout minus b and the name of the branch you want to switch to. You can merge changes in future branch to the main branch by using git merge command. For example, let's say I have done something on the new analysis branch and I want to merge it to the main branch. What I will do is that I will check out to the main branch and then I will now use the command git merge and the name of the branch. Then this will now merge everything on the new analysis branch into the main branch. You can see a concise visual log of your Git repository by using the command git space log space hyphen hyphen one line space hyphen hyphen graph space hyphen hyphen decorate, and that will show you a concise visual log of your repository. Now let's talk about amending a Git commit message. Sometimes you may need to fix a commit message or add more changes to the most recent commit. Git allows you to do this easily by using the command git space commit space hyphen hyphen amend. This is often used when you catch a small mistake right after the last commit. And to do that, you will follow the following steps. First, if you have a new changes that you want to add into the same commit, you can do that by using the git add command. And if you want to change the commit message without adding any files into the commit, then you can skip this git add command. Now to amend the commit, you will use the git commit space hyphen hyphen amend. This command open your default editor, which could either be Vim or Nano. Alternatively, you can amend the commit directly by using the command git commit space hyphen hyphen amend space minus m and you put your commit message. Adding the minus m option allow you to pass a new message from the command line without being prompted to open an editor, just like you will do when you use this. Now you can verify amended commit by using git log -1. This will show you the most recent commit, which will reflect the amended message and any changes you stage before amending. If you haven't pushed to the remote yet, you can easily do that by using git push. And if you have already pushed into the remote, then you will use this command git push space force. And you must be very careful, because forcing push rewrite commit history, and you should only do that if you are certain that no one else depend on the old commit. And in fact, you must communicate with your team if this is a shared branch. Now let's see how to handle merge conflict, because you always see that one often when you are using version control. When you encounter merge conflict, it is important to handle them methodically to maintain a clean code base. First, you have to run the git status to see which files have conflicts. This command will list any file that needs your attention. Next, you open the conflict file in your text editor. You will see the marker like less than or equal to or greater than, indicating the conflict sections. Carefully compare the differences and decide how to merge them, either by choosing one side or combining elements of both, or rewrite the section entirely. It depends on how it comes. Once you have resolved the conflict, you must save your changes and state the file with git add then the conflicted file. Finally, you commit your changes with a message such as resolved merge conflict in that conflicted file to document the resolution. This process not only helps you in cleaning up the conflict, but also ensure that the project history accurately reflects your conflict resolution strategy. Now let me show you about two popular remote repository websites, which is known as either GitHub or GitLab. Git or GitLab is a website that allows you to store your code on the cloud. It is not just a cloud storage, but a version control system powered by Git. GitHub and GitLab are both open source platforms, which means the software is free and the source code is available for others to study and modify. It has a collaborative features. For example, both the platform offers collaboration features such as pull requests, issues, wikis, which allow multiple people to work on the same project and communicate efficiently. Git and GitLab can integrate with varieties of other tools, including continuous integration, testing frameworks, project management software, making it easy to incorporate them into your workflow. Both GitHub and GitLab have large user communities, which means that there's a wealth of documentation, tutorials, and support available for any user. Let's see how to set up a GitHub and a GitLab repository. For a GitHub, what you need to do is to first create a GitHub account, and then you create a new repository, and then you can clone the repository into your computer. Then you add your file to the repository, and then you commit changes and push them into the remote repository, which is on GitHub. The same thing also applies to GitLab. You just follow the same process that you did for GitHub. You create the GitLab account, you create a new project on the GitLab, you clone the project to your computer, you add your file to the project, then you commit changes and push them into the remote repository on GitLab. For the first time user, what you need to do after you have downloaded and installed Git on your computer is to open the Git and then put on this command git config space -global space user.name, and you put the username on your GitHub or GitLab. And then for the email, what you do is that you have to also write the command git space config space -global space user.email, and you put your email in this quotation, and this will now set up the Git configuration on your computer. Now let's see the path toward reproducible research using version control. What we do is to choose a workflow, and you can do that. For example, you set up version control system, you clone the repository, you create a new branch, you work on your research, you commit your changes, you merge and you push, and then you can do documentation and communication. As you know, this workflow is iterative, so you continue doing that until you are done with your project. Then you must always organize your files. As your code is increasing or as you are adding more files, you continue following this workflow. Documentation is very important. Make sure that you add descriptive commit message and you comment your code appropriately so that Git can track them and make it easier for others to understand. When you are collaborating with others on a reproducible design project, you need to assign roles and responsibility to avoid confusion or conflict. You must decide who will lead the project, who will contribute, and who will review and approve the code. You use pull request and issue to review and give feedback on code changes, report bugs and ideas, or track progress of the project. Then you must set up a code of conduct. Setting up code and conduct ensure that all contributors are aware of behavioral expectation and behavior that are required while working with others. Now let's see how to collaborate effectively on GitHub. To work on GitHub, first you need to create a GitHub repository, and it is important that the repository you have on your local computer, the name is the same name you have for your GitHub repository. When you are doing that, you don't need to initialize a readme if you have one locally. So what you just do is to ignore that during the setup. And then after that, you need to add remote by using this command git remote add origin and the full path of your Git repository. After you have done everything, then you can push your code into remote by using git push -u origin main. This will then push all your code that you have in the local repository on your computer into the GitHub repository. Now, how to create a pull request. Before submitting a pull request, you need to create feature branch that isolates your work. This approach keeps your changes separate from the main branch until they have been reviewed, tested, and integrated. Pull requests are a key part of reproducible workflow. They allow team members to review your changes, discuss improvement, and make sure that all the codes meet the standards before merging into the main branch. This collaborative process improves code quality and enhances team knowledge sharing. And here are the step-by-step instructions for creating a pull request. Number one, you need to create a feature branch, and you can do that easily by using the command git checkout -b then the name of your feature branch. Then you make your changes. For example, edit files, add new code, and test your changes locally. After that, then you commit your changes by using git add dot, and then you use git commit and then the descriptive message of your changes. After that, then you push the branch to the remote by using git push -u origin and the name of your future branch. Then you visit GitHub repository to create a new pull request from your future branch to the main branch. Then after that, a team member will review your code. You can also discuss together, suggest improvement. Once your pull request is approved, then deleting merge the pull request into the main branch and optionally delete the future branch that you have created. Now let's see best practices for reproducible workflow. Number one, frequent commit. And you can do that by making small and descriptive commits. Two, you must understand the branch strategy. You always use your branch to isolate new features or experimental features. Documentation is very important. You must maintain detailed readme file, inline comment, and change logs. Then regular backup. You must always push changes frequently to remote repository. Don't just say that when I'm done with everything, then I will push to the remote repository. No. Anytime you have made a change, always make sure that you push it to the remote repository. Then you can always use a tool. For example, in R programming, you can use renv package to capture your computing environment. I will show you before the end of this video. Now let's see how to troubleshoot common issues when using version control in your project. First, you must know how to merge conflicts. For example, you can start by using Git status to identify conflicted files, and you must resolve it either manually or by using merge tools. 2. When you lost any commit, then you can use git reflog to recover the lost commit. It is time for the lab session where I will walk you through everything I have discussed in this video. To follow along this laboratory session, you need to first download and install Git Bash on your computer. I have Git Bash already, so I will come on the search bar here and then type Git Bash. Git Bash. This is my Git Bash. As you can see, to verify that your Git Bash can work effectively, then we can do that by using git space then press hyphen then version and press enter. As you can see, I have this version. That means that my Git Bash can work effectively. Now you need to configure your Git Bash. If you have not done that before, you can do that by using git config then space hyphen then global space user.name and then you now put the username for your GitHub. If you don't have GitHub before, you need to create a GitHub account, and you can easily do that by visiting github.com and create the account. For example, I have the account already and I have my username. My username is gbganalyst, as you can see it here. This is my username. So I will come here and then type gbganalyst. Then you press enter. I've already configured my account, so I don't need to press enter. But in your own case, you press enter after you put your username. Then the next thing is to also configure your email. In this case, you will use the same syntax, but you change the user.name to user.email. In this case, you just type user.email and then you put your email there and press enter. After you have done that, then you have successfully configured your computer for version control. In this laboratory, we'll be working with this repository called database. Remember this database directory, right? Where we talk about ggplot2 and base graphics for our visualization. You know, we have these two scripts. This one, database project script, database project script 2, and then we have all the files that we produce from those visualization. For example, this is diamond area plot, and we also have data set directory. For example, we have data like diamonds, art, and US economics. So we set up our version control in this place. Remember, this one can be called local repository, right? And we have not set up version control on it. So what I will do is to copy this directory, as you can see, database, and go to my GitHub and create this repository, database. So let's go there. In this case, I will use my own account and create a new repository. Now, I will create a new repository here by coming here, create new repository. Then the same name on my local computer is what I will create for this new repository. It's asking me who is the owner because I belong to different projects and different organizations. For example, I'll develop Thomas Allen University, but in this case, I will choose my own as my account. I will use GPG Analyst as my account, and then here in the repository name, I will just say database, the name of that file on my local computer. As you can see, it's telling me that the name is available. If the name is not available, then you can retry another name. But it's always available so far you are using your account and you have not created the same project before on the GitHub repository. Then you can scroll down. Here we have description. That is the description about your project. If you don't have the description yet, no problem, you can redo it later. Then it's asking you whether it is public or private. In this case, I will choose public. Public means that anybody online can view it. But if you make it private, that means that nobody will be able to see it online except I add them into this repository. So I will choose public. Then here is asking me to add a readme. I have already created a readme on my local repository, so I don't need to create another readme, so I will just neglect it. And then it's asking me if I want to create the .ignore file. The .ignore file is where you can escape the file, so that it will not go to the remote repository. In this case, I will just say none. Then here is asking me to add a license. This is the license that govern who and who can work with your project. For example, if it is MIT, that means that it is free and everybody can use it. But don't worry if you don't know any license you want to choose. In this case, let's say I don't want to choose any license, then I will now create the repository. As you can see, the repository is being created. Now, by default, you don't need to memorize any code. GitHub will provide you the code that you will use to push your local repository into the remote repository. So the first thing is telling me to add this, so as to add the readme. Remember, I did not initiate any readme, so I will not do that. The next thing is that it's asking me to press the command git init. Remember, this is what to set up version control on your local repository. So let me now open my local repository. As you can see, this is my local repository. What I will do now is to come to this git bash, and I can change the directory to this repository. But if you don't want to waste your time, what you can do is close this place. Let me close all the git bash that I have opened, and then on my local repository that I have here, I will just right click and then click on show more options. I'm using Windows 11. In case you don't have this, just find a way to do it. Then you will see open git bash here. So if I click on this, by default it will automatically set this my working directory as this, and that's exactly what I want to do. So what I will do now is to split my screen. Let me split it so that you can see it accordingly. Now that I'm already in my working directory, what I will do now is to initiate the version control on my project. Remember, I'm already on my project. What I will do now is to say git init, and automatically it will initialize version control on my project. Now if you look at my project now, you will see that something has been added, and that is this file .git. So anything I'm doing now is being version control, and I can easily recover any lost files where appropriate. Then the next thing after I have initiated version control on my project is to start adding all the files. Remember, I have so many files, so I will not be doing them one by one. What I will do now is to just say git add dot, and this will add all the files to the staging area. Then the next thing is to commit the message. So what I will do now is to say git commit -m, and then I will now add a descriptive message. For example, I can say data visualization projects. As you can see, then the next thing is to copy and paste this git branch -m. I will copy this, press it. Then the next thing is to add the git remote, so that I can link the local repository to the remote repository. In this case, I'll just copy this. I will paste it, right click, paste, and then press enter. So the next thing now is to now push everything into the remote repository on GitHub. So what I will now do is to say git push -u origin main. So in this case, I'll just come here and paste it. Then I press enter. So automatically everything I have on my local computer will be taken to the remote repository, as you can see. So what I will do now is to refresh this my browser. Now you can see that I have everything. So let me maximize this so as to explain it for you. Now you can see that I have all the files. Now I have a good readme. So let me open the readme so that you can see what the readme is all about. I can open it like this, and my VS Code is opening it. So what I have here is that I have the title for this readme, and the title is data visualization project, and I wrote so many things on it. Then I created a project structure so that everybody can understand what this project is all about and how to navigate any file. Then I have this prerequisite saying that before you can work on this project, you need to install tidyverse, inspect df, janitor, and bulk reader package. Then I also show them how to install it. I have many things that you can read at your leisure time. Now let's continue working on this project and let's see how this will affect our project status. Now I can open my RStudio project, which is this one, data viz. So it's opening. So I need to wait. Now it has opened. As you can see, I can resize. Let me say remind me later. Then I can have all of this. So let me close this script and let me open the first script, which is data viz script 1. Data viz project script 1. As you can see, I have everything here, the packages, so I can run everything. As you can see there, I use data sets like empty cars, I use diamond, I use ggplot2. Everything is highly reproducible. In fact, I can even source it. So if I click on source, you see that all the files will be generated, everything. You can see that everything is running. Now you can see I don't have any error. So if you run it on your own too, you will get the same result. And I can easily see the visualization that it produced. For example, it produced diamond area plots, and this is my diamond area plot, as you can see. Then it also produced this scatter plot with base graphics, as you can see. In fact, what I can also do is that if I don't want to use this git bash, I can actually work with my RStudio by coming to terminal and then start using git command. For example, I can just say git status, and that will give me, it will show me everything that changes in my repository, as you can see. Then I can just say git add dot, then say git commit -m, and then add descriptive message. For example, updated the code file during video recording. Then after that, then I will now push my changes to the remote repository. For example, I can just say git push. Now it has pushed it to the GitHub repository. In your own case, what you can do is to create a new feature branch. In fact, before you work on any project, make sure you create a new feature branch, and you can easily do that by using git checkout -b, then the name of the feature branch. Let me just say new project, for example, new project. And when I press enter, it will create a new feature branch for me. And in fact, it has switched automatically to that feature branch, which is this. Then you can continue working with your feature branch, and when you are done, you go back to the main branch, and then you merge everything that is in this new branch in the main branch, and then you now push to the git repository. Now let's see another thing that we can learn from this git repository that we created. If you scroll up, you can see other section like code, and that is what you have as your repository. Another thing is issues. You can file an issue. For example, if something is not working correctly, you can easily file a new issue here by telling the person something is wrong and you would like to work on it, so that you don't waste your time when the person does not want you to actually work on it. So I can file an issue. So I can just say another plot is needed. to explain. Let's just say title should be concise. Let's just say another plot is needed. Then you write your message here. Hello Ezekiel. Okay. Thank you. You can just say thank you for this repo. I would like to know how to use ggplot for lolly plot, for example lolly plots, and you find this issue. You create that issue, as you can see. So anybody that comes to this repository will see the issue that you have created. As you can see, it has added the issue and give it a number. And if I have time, I can easily work on it and then tell you that I have created another plot and I close your issue. So you can use issue for project management or to file an error for a particular project that you are visiting. Then we have pull request. So let's say that Ezekiel does not have time, but somebody has time to work on this issue. Then the person can create a pull request, and if I look at it and see that, oh, this is good, then I can merge it to the main repository. And that is how to collaborate effectively with GitHub. It is now your turn to work collaboratively with Git and GitHub. In this assignment, you work collaboratively to practice version control, branch management, and pull request workflows on GitHub. First, you will select a dataset from Google Drive, and you can visit this link to get that dataset. Make sure to choose a dataset that you are interested in. Then you visualize one or more variables using R. In this case, you can use ggplot2 or base graphics. Then you will save your plot image to the visual image directory of the GitHub repository that you will see in the next slide. After that, you will also save your R script to the script directory in the repository. Then you will collaborate via branches and pull requests. You have the following resources. Number one, the dataset. So you can choose dataset in this drive, and then you visit the repository to begin your analysis. You need to clone the GitHub repository. You create future branches for your individual work. You stage, you commit, and you push changes. Then you open and review the pull request. Then you resolve merge conflict where it appears, and then this will help you to practice reproducible plotting in R. Here are your tasks for this project. First, you clone the repository, you create a feature branch, you select and load the data in the RStudio project, then you generate your plot in either ggplot2 or base R, and then you save your output in the visual images directory. You also save your script in the script directory. Then you commit and you push to the GitHub repository. Then you open a pull request. You review the code from your friends, and I will be merging it where appropriately. Here are your deliverables. A mail pull request on GitHub containing the plot that you save in the visual image directory, and a script that you use to generate those plots, and you must save them in the script directory. Then evidence of at least one code review comment on teammates pull request. Have a good luck to your assignment and see you in the next video. Bye.